Okay, in this video we're going to talk about adding and subtracting rational expressions and do a couple of examples. So the first thing you got to know is what a rational expression is. And actually if you know what a rational number is, which is just kind of an integer over an integer, you sort of have a guess about what a rational expression is. So it's a fraction, but it's a particular fraction. So it's a fraction with a polynomial in the numerator, denominator, or both. And so here's a couple of examples. So we could have something like x plus 5 over 4. So x plus 5 is a polynomial. It's actually a binomial because it has two terms. X plus 5 over 4. X squared plus 3x plus 4 over x squared minus 5x plus 1. So that's a trinomial over a trinomial. So that's going to be a rational expression. Or something like x plus 3 over x minus 4. So those are some examples. Basically, anything that looks like that. Also, if you look really closely, I spelled rational wrong. So good job, me. Let's take a look at a rule that we're going to have to follow. So to add or subtract these rational expressions, they must have a common denominator. If they do not have a common denominator, you got more work to do. So let's take a look at what you do if they do have a common denominator. So for example, we could have x plus 5 over x minus 3 plus x minus 6 over x minus 3. So x minus 3 is a common denominator. They both have exactly the same denominator. So to do that, I typically just start by writing the common denominator, and then you just deal with each part of the numerator. So I'm going to create a new numerator that is the quantity x plus 5, and then plus, because that's the operation between the fractions, the quantity x minus 6. So that's how you read something in parentheses, the quantity. And now you just kind of collect like terms in the numerator. So it's going to be 2x's and then minus 1 all over x minus 3. Let's take a look at one more that's kind of similar. So we could have 3x minus 5 over x squared plus 1 minus 4x minus 7 over x squared plus 1. So they already have a common denominator, so that's kind of like half the battle here. So equals, I write the common denominator. Now what I like to do is put each of the original numerators in parentheses. So I'm going to say the quantity 3x minus 5, and then it's minus, because that's the operation between the two original fractions, so minus, and then the quantity 4x minus 7. That's going to help you avoid errors where you don't distribute correctly, which is a huge problem with these sorts of things. So this is going to be equal to the common denominator, and then I have 3x minus 4x, which is negative x, minus well, then I have negative 5 minus negative 7, so that's negative 5 plus 7, so that's plus 2. And that's kind of all we can really do with that one. Let's take a look at something else. So what you always want to do is check that everything is kind of in its simplest form to begin with, because if it's not in its simplest form, you could do yourself a lot of favors by simplifying. So always check that the fraction is simplified. So let's look at an example. So say we have x squared plus 3x plus 2 over x squared minus 4. A lot of factoring we can do there. Plus x minus 6 over x minus 2. So nothing we can really do there. So we're going to deal with that left-hand fraction. So equals, first I'm going to factor the numerator. So x squared plus 3x plus 2 factors into x plus 2, x plus 1 over x squared minus 4 factors into x plus 2, x minus 2. And then you can see we have an x plus 2 in the numerator and the denominator, so we should simplify that. And that's going to be plus the original. So we should simplify. So I'm going to cross both of those out. So really the problem just becomes x plus 1 over x minus 2 plus x minus 6 over x minus 2. So if you didn't simplify this, you'd be doing a lot of extra work that you don't need to do. Now they have a common denominator, so this is all over x minus 2, quantity x plus 1 plus quantity x minus 6. And that's going to be over x minus 2, so it's 2x, so x plus x is 2x, and then 1 minus 6, well, 1 plus negative 6, which is 1 minus 6 is minus 5. And that's all we can do on that one. Let's take a look at something else. So you always want to look for the least common denominator, otherwise things get out of hand really quickly. So let's do some examples. So we've got 4 over x minus 3 plus 2 over x plus 5. They have nothing in common, which means that the common denominator is just going to be the product of x minus 3 and x plus 5. So now we need to build that. So the left-hand fraction, which is 4 over x minus 3, is missing an x plus 5 in the denominator. So what we do is we multiply by x plus 5 over x plus 5. And as you get good, you kind of skip some steps, but until you're really good, you should not skip steps. And it's going to be plus the right-hand fraction. This fraction is missing x minus 3 in the denominator, so to get it there, we're going to multiply the top and the bottom by x minus 3. And now we can kind of clean it up. So they have a common denominator, x minus 3x plus 5, and it's going to be 4, the quantity x plus 5, and then plus is the operation between the fractions, 2 times the quantity x minus 3. So notice I'm using parentheses kind of liberally because you don't want to make a mistake there. That's probably the most common place. And this is going to be, so x minus 3x plus 5, and then I'm going to have 4x plus 2x is 6x, and then, so I'm distributing the 4 and I'm distributing the 2. And then I have 4 times 5 is 20, and then 2 times negative 3 is negative 6. So 20 minus 6 is 14, so plus 14. So you may end there, but maybe the directions are expand as much as possible when you're done, in which case I would just expand the denominator. And I'd get this. So either of those might be acceptable depending on the problem that you're doing. All right, let's take a look at one more. So we have x plus 1 over x minus 1, x plus 2, plus x minus 4 over x plus 1, x plus 2. So this could easily have been given to you in non-factored form, and the first step would have been to factor so we could see what's going on. But if you look at this, both fractions have x plus 2 in the denominator, so that's already there. We don't need to multiply that into either of the fractions, but there's an x minus 1 and an x plus 1. So the left-hand fraction is missing x plus 1, the right-hand fraction is missing x minus 1, so we're going to have to deal with that. So let's do that. So we got x plus 1, and this is just the original left-hand fraction. That needs to be multiplied by x plus 1 over x plus 1 to get the x plus 1 in the denominator, plus, this is the original right-hand fraction, which is missing x minus 1 in the denominator, so we multiply by x minus 1 over x minus 1. And now it's just a lot of simplifying. So I'm going to use a lot of parentheses here. So it's going to be the quantity x plus 1 times the quantity x plus 1, and then a plus the quantity x minus 4 times the quantity x minus 1. And now we just expand like a whole lot. So x plus 1 times x plus 1 gives us x squared plus 2x plus 1, plus x minus 4 times x minus 1 gives us x squared minus 5x plus 4. So I hope you've been practicing expanding because it comes up a ton. And now I need to expand the denominator. I'm going to kind of cleverly, I guess, multiply x minus 1 and x plus 1 because that's an easy multiplication. That gives me x squared minus 1, and then that's still times x plus 2. And now I'm going to collect terms in the numerator and then expand the denominator. So I see there's 2x squared